Hi everyone, welcome back. So this is another data analysis video. I'm just following on quickly from the previous video that I made where I demonstrated how to detect and remove outliers using the Z-score method. So what I'm going to do is, continuing on from that, this video I'll demonstrate how to do the same sort of thing, but this time we'll use the IQR or interquartile range method for detecting and removing outliers. So if you remember from the previous video, if you've seen it, we were using the white wine data set that I imported, um, and we were looking at the variable residual sugar, which has, if we look at this distribution plot, most of it is positively skewed, significantly highly positively skewed. Most of the data falls between 0 and 20, but we've even got a score that's as high as like 65. And if we look at that here, you can see a minimum of 0.6, maximum of 65.8. But 75% of the values are 9.9 or less, effectively. So what we want to do is we'll use the original white wine data set, and we'll use the same variable in this case to demonstrate again how to detect and remove outliers. Okay, so using the IQR, the interquartile range method, we identify outliers that lie outside 1.5 times the interquartile range. And the interquartile range is basically the middle 50% of values in the data set. It's essentially, if we think of Q1 as being the 25th percentile, Q2 the median being the 50th, Q3 the 75th percentile. It's the values, the scores in our data set that fall between the 25th and 75th percentile. So that middle 50% values. Okay, so first of all, we want to establish what the interquartile range is, and then to find our outliers, we want to look 1.5 times the IQR above the 75th percentile and 1.5 times the IQR below the 25th percentile. Okay, so first of all, let's establish what Q1, Q3 are and what the interquartile range is. So Q1 here, I'm creating an object called Q1, and it's basically, we're taking the YNDF residual sugar variable, and we're just asking we're using dot quantile 0.25. So it'll give us the 25th, the value that's the 25th percentile, effectively. And then Q3 is the same thing. We're using the YNDF residual sugar data variable, and we're going to ask for dot quantile 0.75, so that's 75th percentile essentially. And then I'm going to create an IQR interquartile range object by subtracting the 25th percentile from the 75th percentile. So this expression here, this equation, is just going to give us the middle 50% of values essentially. And then here at the bottom, I'm just going to print out, I'm asking it to return Q1, the value for Q1, the value for Q3, and the IQR. So if we run that, what we can see is, so the value at the 25th percentile is like 1.7, the 75th is 9.9. We kind of know that because we already got that from our descriptives above when I kind of first imported this data set. So 25th 1.7, 75th 9.9, so that has worked correctly. And let's find it again. What we're seeing here is the difference between 9.9 minus 1.7 is about 8.2. It's not rounded that to 2, it's given us quite a precise calculation of the interquartile range. But we can now we've got this, we can use it to find our upper and lower limits, so the values beyond which we would consider something an outlier using this method. So to find the upper limit, I'm going to create a new object called upper limit underscore n for new upper limit, because previously we created an object called upper limit and lower limit when we were doing z-scores. So I'm going to create like a new object, upper limit new, and that's going to be Q3, so the 75th percentile, 9.9, plus 1.5 times the interquartile range, or 1.5 times 8.20 roughly. And that'll tell us the value that is the kind of upper limit or threshold. and any value beyond that we're going to consider an outlier. Lower limit's the same, but this time we're just going to take Q1, the 25th percentile, subtract from it 1.5 times the interquartile range. And if I print out the values that it returns for those two values, so what you're seeing here is we're going to consider anything that's less than negative 10.60, a extremely low value and an outlier, and anything that's greater than 22.20. So I think those, I think those are actually wider. So it's including more values than when we use the Z-score method. Those upper and lower limits. Let's see if we scroll back up, we should be able to see what they are. Those upper and lower limits were negative 8.8 and 21.60. So it's kind of it might be the case that we include where what's under the Z-score formula was considered an outlier in this case isn't, but they're not massively different. Okay, so let's plot the original data again so we can see what the outliers look like. Okay, so you can see here on the box plot using Seaborn, we have these. We don't have any below because none of these values are negative essentially. But there's at least 4 values that we might be outliers using these upper and lower limit thresholds, certainly using this upper threshold here. Okay, so first of all what we're going to do is find those outliers using the .loc method. So I'm calling winedf.loc, so the wine data frame, we're using the locator and we're asking it to find the location of any value of residual sugar that's greater than this new upper limit, so that's greater than 22.20, or any winedf residual sugar value that's less than the lower limit, so it's less than negative 10.6. This isn't going to be the case because we don't have those values, but in the data frame they're all positive values, but we're going to include it anyway, so just in case there are any erroneously entered values in the data set. It might, although there shouldn't be any negative values, it might be the case that someone's entered them wrong. And what you can see is we've got 1, 2, 3, 4, 5, 6, 7. So it's identified 7 values that are outliers using the IQR. And if you remember when we did the Z-score, it identified 9. So there's 2 that are included here that wouldn't have been included when we used the other method. Okay, so having done that, having identified these outliers, we've got 2 options. We can either trim them. So if we trim them using the IQR method, what we're going to do is we're going to delete anything that falls above the upper limit or below the lower limit. So let's do that first. So what I'm going to do is create this new wine df2 object, and we're going to basically we're going to create that by using the .loc method and asking it to select all values from residual sugar that are less than the lower limit and less than the upper limit and greater than the lower limit. So it's what we're asking for here is basically saying create a new data frame object that only includes things that sit within the upper and lower limits set for our interquartile ranges. So we're selecting the ones we do want and thereby excluding the outliers. So let's print these things out. So what I'm going to do is use some print statements. We're going to print the length of our wine data frame. We'll print the length of our new data frame object once we've removed the outliers using this expression. Notice how this is different for when we're using, we're saying look for these items and look for these items, the ones that are less than the upper, greater than the lower. And that's different from when we try to identify what the outliers were when we used an OR statement. Here we've used an AND statement. Okay, so we're going to print the length of the original data frame. We're going to print the length of this new wine df2. So that will be 7 values less if we've done this correctly. And then we're going to print how many outliers there were by printing the original length of the data frame, subtracting the length of the new data frame. Okay, so what we can see here is The original data frame was 4,888 observations long, 498 rows, 4,898 rows. And the new data frame is 4,891, so we've removed 7 outliers using the interquartile range method. And if this has worked well, if we create the box plot again, what we should see is those extreme values are gone, and we've got a much neater box plot where our outliers have been removed. Okay, so that's trimming. Trimming essentially, as I said in the previous video, identify which are your outliers based on the criteria you're using, and then delete them. So it returns a smaller data set. The alternative we could have done here is capping. So we're going to use the IQR method to demonstrate capping. And all we do in this case is we change the outlier values to either the upper or lower limit values. So if the value of an outlier is greater than the upper limit, we're just going to replace that value with the upper limit value. Okay. So to do this, I'll make a copy of the original data frame to work with. So I'll call it YNDF3. And then what I'm doing here is replacing the outliers in this cell that are greater than the upper limit with the upper limit. I've included the syntax there for the lower limit, but we don't have any of those values to be replaced. So the only ones, all 7 of the outliers are greater than the upper limit, essentially. If I run this, and you can see here I'm using the .loc method, saying locate the residual sugar values that are greater than the upper limit. And if I run that, and then we check the box plot, what we should see is the distribution of the data has changed. Those outliers are no longer there. They are, the values, the observations are still there, but the values of each observation has been replaced with a new value, which is just this maximum here, essentially. Okay, and if we check, so remember the length of the data frame was 4,898 observations, and if we check the new data frame, it is still the same length. So we haven't, unlike when we trimmed, we deleted values and reduced the size of the data frame. In this case, we've capped them rather than deleting them, and we've retained the same size data frame. Okay, so pros and cons to doing both. So that was the IQR method, the interquartile range method. I will make another video demonstrating the percentile method for removing outliers. Okay, thanks very much. Hope this was useful.